its change, either its composition, structure, all related to the matter we study in the chemistry, and this comes to other chemical combination or the chemical reaction. For this, there are various laws, but we will discuss only important one: the law for conservation of a mass. Number two, law of a constant composition, law of a definite proportion, law of a multi-proportion, law of a reciprocal proportion. These are four laws we will discuss in this chapter. Now, first law we have in law of a conservation of a mass. Uh, Law of a conservation of a mass. Conservation means it's a mean protection, preservation. Conservation mean preservation or a protection. So, law of a conservation of a mass was put forward the French chemist Lavoisier, 1785. Uh, According to him, it gives the statement in for this law having the statement. It states that mass is neither created nor destroyed during a chemical reaction. From this we get that mass can change one form to another form, but it cannot be destroyed or not be created. And in other words, we can say in a chemical reaction, the initial weight of a reacting substance is equal to the final weight of the product. Means when two or more substances are reacting together, they having the some specific weight. After the completion of the reaction, it having the same weight. So it that term verify the statement in any chemical reaction, the initial weight of reacting substance always equal to the final weight of the products. These are the two two types of way to explain the law of a conservation of a mass. But both have give the same sense. Mean mass is neither created or not destroyed. Means it changed from one form to another form. For example, we are having a piece of iron. When we have a piece of any piece of iron, when we expose to a air, when we expose to air, the iron having the rusting that goes through the process of a rusting. Because of a rusting, it gains the weight. It means that in rusting reaction after that, iron react with the oxygen. When they react together, then iron rust is formed. Then the weight increase in iron because of a oxygen from the air or the atmosphere it reacts. But actually, it having the same weight of the iron. Now, law for conservation of a mass, we can understand with the help of an example. We having the water. Water is a union of a hydrogen and oxygen. Hydrogen and oxygen combine together, they form a water. Look at this diagram. Hydrogen occur in a diatomic form. All gases, hydrogen, oxygen, nitrogen, chlorine, bromine. All these gases occur in a diatomic form. Means H2, O2, N2, Cl2. So it means all gases occur in a diatomic form. So two hydrogen atom, H2, and here is a oxygen. Hydrogen and oxygen, they react together. Now look at this. After the reaction, now water form. For the formation of a water, two hydrogen atom and one oxygen atom react together and they form a water. So we can say if the hydrogen and oxygen are weighted before they unite, it will be formed that their combined weight is equal to the weight of water formed. Mean whatever the weight of hydrogen, for suppose we having 1 gram, just for suppose we having 1 gram hydrogen and 2 gram oxygen. So just for we are supposing when we combine together, we get the water. It having the same mass like a 3 gram. 1 plus 2 is equal to 3. So it's mean the initial in the any chemical reaction, the initial weight of a reacting substance is equal to the final weight of the products. So this example is proving the above statement, the initial weight and final weight of the substance remain same. We can get another example. Suppose if we are making any solution of a, for example, we are making the solution of a water and a sugar. We will take 1 glass of a water, we are adding 1 spoon of a water. They combine together and we are mixing with the, or stirring with a spoon, we can get the sugar solution. So it's having the same quantity as we have taken before the reaction. So before reaction or after reaction, they having the same weight. So this example proves our statement initial weight of a reacting substance is equal to the final weight of the substance. This law of a conservation of a mass, is proved experimentally with the help of a Landlord experiment after the name of a scientist, Landlord experiment. Uh, German chemist H. Landlord studied about 15 different chemical reaction with a great skill to test the validity of law of a conservation of a mass. So for his experiment, he take AgNO3. AgNO3 is a silver nitrate. This and HCl. HCl and AgNO3 silver nitrate, HCl hydrochloric acid. For this, he took the H-shaped apparatus. This is H-shaped apparatus. It having 2 limbs. This is 1 limb and this is second limb. He called first limb A and second limb B. In a limb A, AgNO3 is placed, and in limb B having the HCl. Then after putting the AgNO3 and HCl, both end of the H tube shape apparatus is sealed. Why he sealed H-shaped apparatus? Because the solution will not go or escape outside. To remove, it can be removed by any way. So escaping is removed by sealing. Now, after sealing, we will weigh out the H-shaped apparatus, and after weighing, he shaked H-tube apparatus and mixing the chemical reaction occur. It's after chemical reaction, AgCl, silver chloride, and and nitric acid is formed. So AgN3 plus HCl reacting together, it will form a silver chloride in a form of a white precipitate or PPT. Precipitates are insoluble particles which settle down in a chemical after completion of the reaction, and HNO3 in a form of a liquid. When shaked, AgNO3 and HCl in a H-shaped tube, then we will get AgCl plus HNO3. After the end of the reaction, he again weighed. So he found the same result. So from this, he gets that total mass of the substance before the reaction is equal to the total mass of the substance after the reaction. So this experiment verified the law of a conservation of a mass. Now, in our book, experiment has explained, I'm just repeating, take a H-shaped apparatus, it having 2 limbs, A and B, with silver nitrate A filled and hydrochloric acid HCl in a limb B. The tube was sealed so the material could not escape outside. The tube was weighed initially and vertical position, and the solution shouldn't intermix with each other. The reaction were mixed by inverting and shaking the tube. The tube was weighed again after the mixing. He observed the weight remained same. So Landlord experiment is a practical verification of a law of a conservation of a mass. It proving that mass is neither created or not destroyed during a chemical reaction. So this is a this experiment is also called H-shaped tube experiment. In our book, that topic name is landlord experiment or a practical verification, but we can also call is H-shaped tube experiment. Now, from now this, we will move toward the next law. Next law is law of a constant composition or law of a definite fixed proportion. Constant composition or a definite or a fixed proportion, all having the same meaning, when they having a fixed or the same proportion. This law was put forward French chemist Louis Proust in 1799. He performed a lot of experiments or series of experiments. After the experiment, observation finally reached to the statement. According to him, it states that different samples of the same compound always contains the same elements combined together in a same proportion by mass. It's different samples of the same compound. If we are taking any compound, but we are taking its sample from a different resources. So this law says always contain the same element. Compound is the same, it having the same combination of element, but we are taking the sample from a different places, combined together in a same proportion by a mass. Mean this compound elements are present, they compound in a same ratio or the same mass of the elements. So we can understand this law by an example. For example, we having the example of water. Formula for water: H2O. Two hydrogen and one oxygen. Hydrogen having the mass 1, but it having the two hydrogen atoms, so its mass is 2, and oxygen mass is 16. When we plus 2, we're having the ratio 2 is to 16, so it's a simple multiple of 1 is to 8. It's mean that water having 1 is to 8 parts by mass. We are either water taking from a river, it's maybe a pure water from a rain, either we are taking water from a water pump, either water we are taking water from a laboratory, either we are taking the water from our house. So all types of water having the same proportion of a mass, a combination of elements. So from this example, we can say that different samples of a same compound always contain the same element combined together, same proportion by mass. So the let's see, water having the H2. We are taking water from anywhere, it having the same proportion of hydrogen and oxygen. And we can take example of a NaCl, sodium chloride. We are taking the salt from any resource, either it's natural, either synthetic or man-made, having the same composition NaCl. Now, another very good example that help us to understand the law of a constant composition. It was this example I was explaining J.J. Berzelius, a Swedish chemist. J.J. Berzelius, 1779 to 1848. He worked on a different part of a chemistry, but especially he worked on a constant composition or a definite proportion. For this, Berzelius taking 10 gram of a lead and with a various amount of a sulfur, he got exactly 11.56 gram of a lead sulfide, and excess of a sulfur was left over and unused. Means for the formation of a lead sulfide, we need lead and sulfur. Always we need lead 10 gram and 1.56 gram of a sulfur. The total mass is 11.56 gram. If Here, suppose we are using 2 gram instead of a 1.6 gram of a sulfur, remaining sulfur unused. Remaining sulfur remains unused. Why? Because for completion of this reaction, we need only 1.56 gram of a sulfur. For more clarification, now for next time we change the quantity of a lead. Instead of a 10 gram, we use 18 gram of a lead and 1.56 of a gram of a sulfur. So 11.56 gram of a lead sulfide obtained, and remaining 8 gram of a lead remain unused. So J.J. Berzelius gave the more clarification of this law that different samples of a same compound always contain the same element combined together in a same proportion by mass. So J.J. Berzelius proved it practically and with a more clarification, and one example, more example I have shared with the water. What we are taking water from any resource uh, with having the same composition. So this is all about the law of a constant composition or a law of a definite proportion. Now next is we having the term atomic mass. The atomic mass of an element is now taken as the average mass of a natural mixture of a isotope, which is compared to the mass of one atom of a carbon 12 AMU. Atomic mass of element is not in average of a natural mixture of isotope. We are having the term isotope. Isotope. We are having the term isotope. It can be defined at element having the same number of a proton but different number of a neutron. What is isotope? Having the same number of a proton but different number of a neutron. On either the say, so all mixtures of a mean natural mixture of isotope have different elements having the isotope, but all elements don't have the isotope, which is compared to the mass of one atom of a carbon 12. Carbon 12 is taken as a standard by which we compare the other elements, and we can explain in a more detailed way. So atomic mass of element is taken as the average mass of a natural mixture of isotopes, which is compared to the mass of a one atom of a carbon 12. So we can compare with mass of any element with a carbon 12 one atom, and its unit is AMU, that is the atomic mass unit. And atomic mass unit, I have already told you, but I'm once again repeating. Atomic mass is, is a is a mass of a atom in a atomic mass of a unit, or precisely 1/12th mass of an atom of a carbon 12. Now, for example, the atomic mass of oxygen is 16 AMU. The and sulfur having 32 AMU, and we having hydrogen, it having 1. uh, so we having these three different examples. Now we having another term, empirical formula. Empirical formula uh, is that formula which describes the smallest or the least ratio of the combining atom of our different elements present in a molecule. Means in a molecule different elements are present, how they are combined, their simplest ratio is shown in a form of a empirical formula. Actually empirical formula does not tell us about the actual number of atoms are present in a certain molecule. For example, we have we are considering benzene. Its formula is C6H6. Now, the ratio of a carbon to the hydrogen atom in this molecule is 6 to 6, or simply we can say 1:1. The empirical formula of the benzene is therefore written as CH. So, uh, the empirical formula only tells us that how many atoms or the elements are the present, but do not explain or exact ratio of a carbon or hydrogen. That's why it's not authentic as compared to a molecular formula. Next term, we having molecular formula. Molecular formula indicates the actual number and the type of atoms in a molecule. It can either be same as empirical formula or some simple multiple of it. Means this is a basic difference between molecular and empirical formula. It's tell us about the actual number, but molecular formula does not give the actual number. So this is a basic difference between molecular formula and empirical. This will give the different actual number. We having the example of a carbon dioxide. It consists of one atom of a carbon combination with two atoms of a oxygen. The formula of a CO2 is the molecular formula of a carbon dioxide. In empirical formula, we having the molecular formula of a benzene is C6H6. That is the molecular formula, but but in molecular formula, its formula is C6 and H, but empirical formula is CH. So this is a basic difference between molecular formula and molecular formula. Now molecular formula mass. The molecular formula mass or molecular mass of a substance, the sum of the atomic mass of all atoms present in a molecular formula of a substance or a molecule. Its molecular formula mass is a sum of a atomic mass of atom present in a molecular. Means we having the molecular formula. For example, carbon dioxide. Right? Carbon having 12 atomic mass, it having number 1 carbon atom, that's why 12 AMU. And oxygen having atomic mass 16 and it having 2 oxygen atom, that's why multiply with the 2. So we will get the 32. So when we sum up, then we will get 44 AMU. Now, this is all about uh, today's task. We have now we having the home task. First question, we having the state the law of conservation of a mass. Second, state law of a constant composition. And we having the third question, define the following terms: atomic mass, empirical formula, molecular formula, mass. Uh, Please take a screenshot of the home task and previous slides. From previous slides, you can get the answer of these questions. So you have to complete the home task in your fifth copy. Now, and please do it with instructions. This is all about the home task. Now it's all about in, it's all about today's home task. Now you have to complete in a your complete fair copy